Hey guys, thanks for tuning in to another episode of Jack's Mechanics. Just got this Mitsubishi Triton here. I'm not sure on the year at the moment. I'll grab that for you. Customer complaint is intermittent low power, or it breaks down on acceleration. It is a diesel. I think it's a 2.5 litre turbo diesel 4D56 engine. So Dr. Google has apparently told him that it needs a suction control valve, which we know that these are reasonably common for. Definitely done some in the past. So I'm just going to have a look if we can get some fuel pressure readings and see what's going on. That fuel rail pressure. Sort of wish we had desired fuel pressure. Might have to go into the enhanced data rather than just in the OBD here. Alright, we'll just go out and go into the enhanced data. I'll grab the year and get you on that next screen. Okay, so it's Triton MN 2.5. This is a 5-speed manual. Okay, nothing in the engine codes. Okay, that's what we want to look at. So what we might usually see with a bad suction control valve is the fuel rail pressure bouncing around. Just got the RPM bringing up a little bit. Drop it down to idle. Looking pretty good at the moment. I'll take it for a quick drive and have a look at the readings and see what happens. So my phone's playing up a bit here. Looking at the target pressure down the bottom and actual fuel rail pressure just above that. Not seeing like major discrepancies to sort of indicate that we may have a sticking suction control valve. Honestly, the car's performing pretty well. You can see our min-max on both the low and the high is pretty close together. Just going over these at the bottom still, making sure that they're all looking pretty matched up, which they are. Just I did leave it running for like 20 minutes, maybe warm up the pump a bit and the valve, and maybe that's when this thing would play up. It's a bit lower on this point here. Go over. It's not. Some parts, I guess, yeah, it is a bit out. This is the target one down the bottom and the actual one up the top. Ones that I've seen before have been a lot worse, and the rail pressure would stick high or stick low, where the target is changing a lot. See the boost pressure that we have here, target boost is 157 kPa. Actual boost is pretty low. So maybe it's not a suction control valve issue. Maybe there's something else at play here. Yeah, the boost, we look at the top and the bottom, definitely looking a lot more uneven than each other. Fuel rail pressure is looking pretty good, maybe a bit lower at this point. Yep. I did see on my first test drive a lot of black smoke out the tailpipe, indicating incomplete combustion, excess fuel, or not enough air. 200,000 Ks. Maybe I'll have a bit of a blocked up intake. I'll go back and see if I can question the customer. I haven't even had a look in the engine bay yet, so I might just have a look over the engine bay, see if I can find anything odd. We'll go from there. So just doing our engine bay inspection. Might be a bit hard to see, but all that black stuff down there is soot. You can see it sort of all over the place. First of all, I was looking at the oil underneath there, which could be an indication of this hose being a bit loose. And maybe a bit of boost leaking out. If we can have PCV leaking out, we can definitely have boost leaking out. Same with this one, boost hose. Definitely loose. You can see all the exhaust, and it's quite a way underneath there. That bolt there with the shroud on it is for the EGR. Got the EGR cooler down here, EGR valve. So my guess is somewhere around there that we've got some exhaust leak. So that's obviously not ideal. Don't think, just trying to think about it. Don't think that should, I don't know if that's on the boost side. If it's on the exhaust side, shouldn't worry it too much. I might smoke test it and see if I can find out where this leak's coming from. Smoke test the intake as well and see what we've got going on. So I've just got some clear hose teed in. This is basically after the fuel filter, but before the high pressure pump. And we're just checking for air ingress. There is a little bit, as you can see there, a little bit more when it's actually driven and loaded and pulling hard on the fuel system. We are allowed some air. That's what I've been taught is like sort of champagne bubbles. Let's move out of the way of this car. And basically it does have some, and I'm probably going to recommend that the fuel primer, the fuel filter housing gets replaced. I've replaced some in the past for this particular issue, but don't believe that this is our issue with this car. Yet we're still yet to feel the said issue of low power intermittently, but you can see just some more bubbles when we rev it up. but not really much more than that coming through at one time. Still haven't got it to play up, so I think this sort of warrants enough to maybe just pull the suction control valve and inspect it, as well as recommend the fuel filter housing. I know in some of these common rail systems there's a couple of suction control valves, and there's a short one, and then there's one that actually has a longer body, and the longer body is like the updated version. The short ones did have a lot of issues. This one has got the long body with the blue cap on it, and yeah, so that sort of doesn't give me much faith, but I can't really find much else wrong with this thing at the moment. So I'll just speak to the customer and see what they want to do, see if they want us to pull it apart and inspect the suction control valve, and then maybe just put one in there, but obviously warn him that we haven't found anything other than that exhaust leak, which obviously isn't going to affect our boost reading in the manifold, but we had those sort of loose boost pipes which I tensioned up. I did smoke test it, though our smoke tester is only low pressure and couldn't get any smoke out of there, though we'd definitely seen oil mist from the PCV system, so it's almost guaranteed there was some boost leaking out. I'll take it for another burn and have a look, see if our boost readings have improved at all. Failing that, I think we'll pull the suction control valve and inspect, so that'll probably be in the next frame. So we've got the old suction control valve here, obviously pretty gross on the outside. Unfortunately, this style cannot pull it apart. You need a special tool to get that plug out. Basically pull it out, that's like a press fit in there, and basically the piston just moves in and out and controls the fuel going into the rail. So, sorry, into the pump. It's just a little 2-wire in and out. I think it's probably pulse width modulated. So we called the diesel guys. That's the new suction control on the back of the pump. Got to be very careful. You want to keep everything very clean when you're doing this job. So don't pull it out until you sort of have a new one, or you can keep the area clean. New one's in there, plugged in, ready to go. Not too bad of a job to get that out. Little Allen head there, then through the wheel arch you can get to the other one. So usually on the other suction control valves I've seen a little circlip on the end. You can pull the circlip out and the piston will pop out. There's a little spring behind it. So fortunately not on this one. The diesel guys said that they had 13 of these particular ones in stock. They go through them all the time on this thing. On my last test drive, which I will show you guys in the scan tool, it actually was like 20 K, what am I trying to say? There's like 20, I think it was 20 millibar difference between the desired and the actual fuel pressure. So based off that and our good reading on our fuel hose, we are replacing the filter housing. As you can see, it's just teed in there. We want it basically coming out here, so if it's drawing in air through this top gasket here, or anywhere in the filter, we will see it come through the line. So that's on there. Plug the scan tool in, go into the functional test, and we'll relearn that it's got a new suction control valve. We'll take it for a burn, see what happens. So we need to get the coolant up to 60 degrees and the fuel temp up to 30 degrees. No accelerator. So we'll just go back before we can learn this and warm it up. Show you those other two. So we have this one. So I was accidentally couldn't remember what I was trying to say with the reading. So 20 megapascals, roughly 20,000 kPa. Obviously a pretty big variation there. And then we got the same again on the other one. These are just frozen images from the last test drive before actually calling the suction control valve. Again, another roughly 20,000 kPa, 20 megapascals. So I'll get this up to temperature and basically just hit a few buttons to learn the suction control valve. Take it for a test drive, and this one should be just about ready to go. So we're up to temperature on both coolant and on the fuel temperature. So basically just hit initialize. So we need this learn status to go to 2. So not 100% sure why that I'm not initialized, but our high pressure pump learn status is 2, and that's where it needs to be. So if we scroll down here, confirm that the high pressure pump learn status value is 2. Select back to exit. Maybe that was the final step. Exit there. Just check for codes. It's the same codes as we had before, some communication. We've got our learn status there. I'll just take this for a drive and see what these rail pressures do, and we'll get you back on it. Everything's looking pretty sweet, guys. Can't really find any major discrepancies in this one, and the last one was a bit iffy as well, but we couldn't really find anything to point us in another direction. So we're just gonna have to let the customer take this away and see. Like I say, we know we have problems with these suction control valves, so chances are it's really fixed. But I hope you took something away from this and helped you out in some sort of way. And yeah, I would appreciate it if you could maybe like it or subscribe to the channel. That would help me out, and we'll catch you in the next one. Take care.